Hello students, today's agenda is to check homework. We're going to be learning about stretches and dilations, and you will be able to work on 9.4. Today students will be able to sketch stretches and dilations. And so stretches, you're going to have either horizontal stretch, is like an accordion that you move to the sides, or vertical stretches, which is up and down. Okay, and so we're gonna start with it says stretch the following horizontally by a factor of 2. Horizontally means to the sides, and so sorry I kind of started on this one, but I'll explain it again. So this line, the green line, was not there, and also the blue was not there. It was just the shape, the triangle, and the dot. That's all you are given. And so it says, when it says stretch horizontally by a factor of 2, what you can do is to draw an imaginary line. You don't need to, but it's easier to see. And it's going to be along the dot that they give you. And so what it means is that each of my vertices for the triangle are going to go away from that line. I know it says through the point, but it says through that line, you're going to stretch it by a factor of 2. So if this is my vertex, this vertex is away by 2 spaces from this line. And so we multiply by 2. And so 2 times 2 is 4. And so it's going to be 1, 2, 3, 4. That's my new vertex. For this vertex, this is also 2 spaces away from that line. And so I multiply 2 times 2 is 4. So 1, 2, 3, 4. And I stretch it. It looks more stretched. So now and this vertex, it's right on the line. So that means that it's 0 spaces away from the line. 0 times 2 is 0, so that means that I move it 0 spaces, so that's why it stays in there. And now I'm ready to trace my 3 new vertices. So the blue shape is my new stretched shape, okay? And I stretched it by a factor of 2. The next transformation that we are going to do is a vertical stretch. And so it says stretch the following vertically by a factor of 2. And so if I'm going to stretch vertically, it has to be away from this point. So basically I can again just draw an imaginary line in there so that I can know how many spaces. So in here, and in here, how far away from that line is each vertex. So this vertex is 1, 2 spaces times 2. It's going to be 4. So 1, 2, 3, 4. And then this is 1 space away times 2 is 1, 2. 2 spaces. Because 1 times 2, 2. So that's why 2 spaces. In here we have 1, 2, 3. 3 spaces away times 2 is 6. So 1, 2, 3, 4, 5, 6. The new vertex is right here. Somebody asked me if the factor is always going to be 2, and well, it's not always 2. In fact, I think I want to do the stretch, same vertical stretch, but now I'm going to do it in pink. And I'm going to do it by a factor of 3. Okay, it's just so that you can see the difference. And basically what you're gonna do now, again from the original, this is 2 spaces. If we multiply by 3, 2 times 3 is 6, so 1 2 3 4 5 6 right here. In here you have 1 space times 3 is 1 2 3. You start counting from the line, okay? 1 2 3. So that's my new vertex. In here we have 3 spaces times 3 is 9. Oops. So from the line it's going to be 1 2 3 4 5 6 7 8 9. Even if I run out of space, I can still kind of like figure out what the other lines would be. Okay, so now I'm ready to connect and see what happens to the figure when you stretch it vertically by a factor of 3. Okay, so yeah, it's not necessarily only by a factor of 2, but it can be other factors. Now imagine by 4. Okay, so now we're going to stretch the following figure vertically by a factor of 2 about the given point. What's different about this figure? Well, my point is outside, but I want you to notice that my line is going to be, because before the point was here, so my line is going to be along the same, right, the same height. If the point was either higher or lower, the sketch will be a little bit different, but let's see what happens in here. So this is 3 spaces times 2 is going to be 6. So 1 2 3 4 5 6. This is 2 spaces away from the line, so 2 times 2 is 4. 1 2 3 4. So my new vertex is here. This is 1 space away times 2 is 2, so 1 2. So what do you notice about this shape compared to the one from the previous example? They're the same, and the reason is because it's the same factor, and even though the point is outside, it's at the same level, right? Again, if this was up higher, then it will be probably a little different, or if the factor was different, then the shape would also be different. Okay, and you might want to try it if the point is higher, like what's gonna happen. Okay, let's try now. Says stretch the following horizontally by a factor of 2 about the given point. About the given point. Okay, and so if this stretch is going to be horizontal, that means that my line is going to be vertical, a vertical line. And so again, we're going to look at each vertex and pull it away from that line by the factor that they tell us or they give us. So again, step number 1, draw the line opposite to what we have in here. Step number 2 is to multiply the spaces of each vertex by the factor they give us. And step number 3 is draw the new vertex. So the spaces in here is 2 spaces times 2 is 4. So 1 2 3 4. That's my new vertex. The spaces in here multiplied by 2 is, the spaces are 1 2 3 4 times 2 is 8. So 1 2 3 4 5 6 7 8 right there is my new vertex. So this moves here. And my spaces between the line and this vertex is 0, so 0 times 2 is 0, so it stays there. Now I'm ready to trace the lines between the three new vertices. And one of the vertices stayed in the same position. So that's my new, once I stretch it by a factor of 2, then that's my new shape. Okay, so now let's try, oh, and if we were to stretch it by a factor of 3, that means that this will be triple up to here, and 12 in here, because 4 times 3 is 12, so up to here. So it will look something like this. And then this one would stay in the same position. Okay? Again, you can try different ones with different colors on your same sheet so that you can see the difference. And okay, so those were stretches. Now we're gonna go into dilations. And dilations is, you know, like when you go to the eye doctor, and they put the drops, your pupil dilates. Okay, so that's an example of dilations. Also, when you have a pattern of circles, those are enlargements. Or when you are in the computer working with pictures and you want to make some like a picture bigger, you kind of pull it away. How do you say? Basically, you drag the corner and it makes all the dimensions bigger. So that's what we're going to be doing now. Dilate the following by a factor of 2. So that means that you want these twice as big. Or you just dilate each vertex. So in here we're not going to draw a line like we did for the stretches. But what we're going to be doing, and maybe it will be helpful to draw, I'll see how it goes, how far each vertex is away from the point. So now we're going to compare this vertex to the point, and this vertex to this point, and then this vertex to this point. So this point is easy because it's right underneath, and so it's 1, 2, 3 spaces. If it's a factor of 2, that means that we're going to go 3 times 2 is 6. So 1, 2, 3, 4, 5, 6. My new vertex is going to be here. For this one, it's a little bit tricky because you're going, when I asked, students said, oh, it's 2 squares away, but diagonally. Okay, I said 2 squares diagonally times 2 is 4. So you go to 1, 2, 3, 4. Another way of seeing it is from here to here, you have a slope. The slope is rise is -2, run is +2. Rise is -2, run is +2. So basically, depending on the factor they give you, if it's a 2, you do the slope 2 times. Now, for this vertex right here, my slope is down 1 to do the left. So -1, -2, -1, -2. Since it's only 2 times, the factor is 2, I only do that slope 2 times. Or if you prefer just the line, well, it goes like kind of like 2 squares across, right? So you're going to continue on that, and it's only once, twice. Okay, so either way, whichever works for you best is the one that you want to definitely use. Okay, so those are my new vertices for this dilation. And this is my new triangle. Again, it's like when you have a picture in the computer, you drag the corners, and then this is the bigger version of it. Okay, let's now do a dilation with the point outside, and so that's a little bit trickier, but we'll see how it goes. So it says dilate the following by a factor of 2. So remember that if you need to either pause the video to copy the shapes, that's fine, but the point is right here. Or you might want to see first the explanation and then go back and take the notes. Okay, so it says to dilate the following by a factor of 2 and given this point as the point of dilation. So what we're gonna do, same thing as we did before, away from this point or from this point to this point, what's the slope? Oh, remember, rise is always up and down, and that's rise over run. Your slope is rise over run. This is up or down depending on the sign, and this is left or right depending on the sign. So positive 3, negative 2, 2 times, positive 3, negative 2, that's 2 times the slope. Okay. For this vertex to get here, you go down 1 and 4 to the left. So down 1, 4 to the left, another time, 1 down, 4 to the left, and that's where it's gonna end up. Okay. And then to get to this point from the point they give us, the point of dilation, it's gonna be 2 down and then 2 down. Now somebody asked me, what if it was factor of 3? All it means is that from here you go up 3, 2 to the left, up 3, 2 to the left, up 3, 2 to the left. That means you're going to do the slope 3 times. Okay, and so those are my new vertices. And I'm ready to trace them. Well, those are the examples that I have, but I think I want to do, even though I'm gonna go out of this grid section, I think I'm going to do one for factor of 3 so that you can see the difference. Okay, so how many spaces are we away for each vertex from the point of dilation? Again, or you can even see like, oh, this distance 3 times, so 1, 2, and then 3 somewhere in here. Or you can do the slope, rise 3, run negative 2, rise 3, run negative 2, rise 3, run negative 2, somewhere along this line. And it's a little hard because I don't have the grid in there, but it kind of goes in there. Again, from here to here is negative 1 on the rise, negative 4 on the run. So down 1, 4 to the left, down 1, 4 to the left, down 1, and 4 to the left. And that's my new vertex if I'm doing a factor of 3. To get here, I only go down, so it's going to be 2 spaces, that's once, 2 spaces, that's twice, 2 spaces, that's 3 times. And so that will be my factor of 3 dilation. And hopefully it doesn't look too messy for you, because it's on the same copy. They also use this a lot in art. As you can see, the enlargement It's when something is closer, it looks bigger, and something a little farther, it's a little smaller, and then when it's super far away, it's gonna be a lot smaller, and you can even make it smaller and smaller and smaller. Okay, so now you are able to work on 9.4 with horizontal and vertical stretches and with dilation. So have fun.